So for section 10.2, we're going to look a little more into rational exponents, which are basically radicals. So we're going to look at radicals, but in a different way. See, if I have the nth root of a, we can rewrite that as a to the 1 over n. And you're like, why the heck would we ever want a fraction in the exponent? Well, I'll show you. But basically, whatever the root is becomes the denominator. The root is the denominator of the exponent. So for instance, and let's go ahead and just go kind of the easier way, 64 to the 1/3. I have no idea. This seems like utter nonsense. Well, what is that 3? Well, that denominator of the exponent is a root. This is the same thing as a third root of 64. Well, we can do that. What is the third root of 64? What times itself 3 times makes 64? How about 4 times 4 times 4? So out comes a 4. What is 64 to the 1/2? Well, that 2 becomes the second root. What is the second root of 64? Just 8. What is the fifth root of 32? Well, you're like, I'm not liking that, but how about you could do 8 times 4. 8 is 2 times 2 times 2 times 4 is 2 times. There are freaking 5 2's in there, so out comes a 2. But I need to know that that is the same thing as 32 to the 1/5. See, I can do the fifth root of 32. I can do the fifth root of 32, and it tells me that's 2. But now I know that that also means the same thing as 32 to the 1/5. Trust me, there's a purpose for this. Just stick with me, and I will show it to you. Okay? But before we go on, I'm going to just put this up here for a second. You need to remember your exponent rules. Since we're dealing with exponents, and even as fractions, you have to remember the product, quotient, power, and negative exponent rules. See, the product, hopefully in your previous class you took time to understand that if I'm multiplying two things that have the same base, I can take the exponents and I can add them. Now, you shouldn't have just been doing that in your previous class. We should have been making sense out of what we were doing. The quotient rule, when I'm dividing two things with the same base, I can subtract the exponents. The power rule, when I have a power to a power, I can multiply. If I have two terms that are being raised to the power, each one gets raised to that power. Or if I have a fraction, then each term gets raised to that power. A negative exponent becomes 1 over that same thing. Or if I have a negative exponent with a fraction, the fraction flips and makes the exponent positive. All of this should be review. We're going to be using it, kind of kicking it up a notch. It should have made sense in Math 55 so that we can apply it in Math 51. The answer doesn't change, that the numbers get a little crazier. Okay? Alright, so where were we? Be careful with negative 4 to the 1/2. It is very tempting to call this the square root of negative 4, but that would be wrong. How would I know? Well, order of operations. This negative 4 to the 1/2 has two things going on. It has an exponent, and it has a negative, which is multiplying. What happens first? See, this is really negative, and then 4 to the 1/2. So it's really negative square root of 4, which is negative 2. That is different than this next one, because what does the next one do? Well, it takes that negative 4 and it puts it in parentheses and exponents. So the parentheses is first, so this time it would be the square root of negative 4, which we've already seen is not a real solution. Okay? What if I have 32 to the 1/5? Well, we already saw that that was what? The fifth root of 32, which was 2. What is negative 32 to the 1/5? Well, that would be the fifth root of negative 32, which is negative 2. Why is that different than the even roots? Well, if you have an odd denominator, then that means you have an odd root, which means negatives are okay. If it's an even root, then we will end up with non-real solutions, because you cannot have an even root of a negative. You can have an odd root of a negative. What if I have 1/8 to the 1/3? Well, that is still what? The third root of 1/8. We can do that. If I split it, I get the third root of 1 over the third root of 8. I need to keep those 3's in the roots. Third root of 1 is 1. The third root of 8 is 2. And you could check that. 1/2 times 1/2 times 1/2 would be 1/8. What about 1/8 to the negative 1/8, to the 1/3? It's still the third root, the denominator is the root of negative 1/8. Well, we could split it. Third root of negative 1 over the third root of 8. The third root of negative 1 is okay. That's just negative 1. And the third root of 8 is 2. So both of these will have real solutions. When won't it? On an even root. For instance, negative 81 to the 1/4 is what? What's the root this time? What's the denominator? Fourth root of 81. Where does the negative go? On the outside this time. All of this is grouped. That negative is multiplying by all of it, so it stays on the outside. Fourth root of 81, I believe, is 3. 3 times 3 times 3 times 3 makes 81, so this would just be negative 3. On the next one, the negative 81 is inside the parentheses, so the fourth root of the negative stays with the 81. It was grouped with it. The parentheses trumps the exponent. It happens first, so it groups the negative in there. So what is the fourth root of a negative? Not a real solution. If I have an even denominator, that means I have an even root, which means I cannot have negatives in the root. I will not have a real solution that way. Let's keep going. 8 to the 2/3. Excuse me, there are two ways of handling this. I could treat this as the third root of 8 squared. See that power, this is basically a power, and this is a root. So I can keep that in there. Now that would end up being what? The third root of 64, which is just 4. Or, by our rules of exponents, I can actually take that power and I could move it on the outside. This is kind of an extension of the power rule. And you're like, well, why would I ever want to do that? Well, because the third root of 8 is what? 2. And 2 squared is still 4. So either way, that power can kind of move on the outside, or it can stay on the inside. And there are times where we want it to do one or the other. But either way, the answer stays the same. So what if I had 25 to the 3/2? I could treat that as the second root, square root, of 25 to the 3rd. Do you want to do 25 to the 3rd? Not looking forward to, I don't know, what is that, 625 times 25? I'm not liking that. Or would it be easier to put that 3 on the outside? Well, yeah, because what is the square root of 25? And what's 5 to the 3rd? 5 times 5 times 5 is 125. You're like, are you sure it'd be the same thing? Well, let's check. 25 to the 3rd. 15/625. And the square root of that is still 125. The answer doesn't change. It's just sometimes it's easier to have that power on the outside. Let's keep going. What is this going to be? Well, let's see. Third root of negative 64. Do I want to square it first, or do I want to square it on the outside? I'm going to square it on the outside, because I can do the third root of negative 64 first. Third root of a negative would be negative 4. Squaring that now, negative 4 squared would be 16. 32 raised to the negative 4/5. Our root, fifth root of 32 to the negative, what a mess. You could do this way, or before you did anything, you could have actually flipped it and made that 1 over 32 to the negative 4/5. It will not change the answer. I'm going to go ahead and do it this way, just because that's kind of the way I'm thinking of doing it now. The fifth root of 32 is 2. 2 to the negative 4th is what? 1 over 2 to the 4th, 1 over 16. If I had flipped it, I hope you caught my mistake, the root would become positive, so that this would become 1 over the fifth root of 32, all raised to the 4th, 1 over 2 to the 4th, or 1 over 16. The answer doesn't change. So I tend to like to move the negatives first, but it didn't really clean it up any easier, so maybe saving it was easier this time. But either way, you should get the same answer. Well, dang, this is a fraction to a negative exponent. How do we deal with that? Well, I'm not going to write this as the square root of a fraction all raised to a negative power. What I'm going to do is I'm going to deal with the negative first this time. A negative exponent with a fraction. I can flip the fraction, and it changes it from division to multiplication. So now I can handle this. So we need to remember how to use those rules. So what does this become again? What's the root? Second root of 9 over 4, all raised to the 5th. The second root of 9 over 4, what's the square root of 9? Square root of 4. How about 3 over 2, all raised to the 5th? I know 2 to the 5th was 32. 3 to the 5th would be 81 times 3, I think 243. Double check my math. Okay. So, once again, why are we doing this, right? Not just for fun and giggles. There is a purpose. See, this question right here, 2 to the 1/2 times 2 to the 1/4. I can handle this pretty easy using my rules of exponents. I can say, well, 2 to the 1/2 times 2 to the 1/4 is basically a to the, I don't know what I wrote it as before, x to the a times x to the b, and I can take the exponents and I can what? So this is basically 2 to the, what is 1/2 plus 1/4? Well, dang, I can do that on the side. Give those a common denominator. 2/4 plus 1/4 is 3/4. So this is basically 2 to the 3/4. Or if you'd like, the fourth root of 2 to the 3rd, or if you'd like, the fourth root of 8. And you're like, I still don't see the purpose. Well, originally, we would have seen these questions like this. The square root of 2 times the fourth root of 2. And we're going to be dealing with this more in the next section, but here's the issue. This cannot be simplified. Not in the way it is. And why is that? Well, they have to be the same root for us to multiply them together. But we ended up giving them the same denominator, and we were able to bring them together. But keep in mind, what is the denominator? By giving them the same denominator, We are giving them the same root. So we're now able to bring these questions together, where in the past we were stuck. This could not be simplified the way it was. But when it is in a rational exponent form, I can give fractions the same denominator and add them, and it makes this question solvable. But you don't have to just believe me. I can do the square root of 2 times the 4th root of 2. Let's look real quick. The square root of 2 times, what was it, the 4th root of 2? Oh, ain't that pretty? And at the end we said that was the same thing as what? The 4th root of, I don't remember, was it 16? 8. I'm going to get myself in trouble. So the 4th root of 8. And those are the same answer. We can now bring these together. I think that's a big deal. I know I haven't convinced you yet. We're going to have other applications here later. Let's keep going. What is 5 to the 2/3 over 5 to the 7/3? Besides saying it ain't pretty, we're going to use our rule. What is a to the, or x to the a over x to the b is x to the a minus b. I can treat this as 5 to the 2/3 minus 7/3. 2 minus 7, 5 to the negative 5/3. Do not leave it like that. Do not leave a negative exponent. I would want that written as 1 over 5 to the 5/3. Or 1 over third root of, what, 5 to the 5th? That ain't going to be pretty. I'm okay with this answer at this point. You're doing what we want. Because this actually could be simplified and messed with, and that's not really the point of this section at this point. It's can you apply the exponent rules when it gets a little more complicated. For instance, 9 to the 2/3, x to the 1/3, all raised to the 4th, over 9 to the negative 1/3. How do we deal with this negative exponent? Well, when it was negative up here, we could bring it down. If it's negative on the bottom, we can bring it up. So what I end up with is really 9 to the 2/3 times 9 to the 1/3 times, how about x to the, here's a power rule, what is 1/3 times 4? What is 1/3 times 4 over 1? How about x to the 4/3? 9 to the 2/3, 9 to the 1/3. I can take those exponents and add them. What is 2/3 plus 1/3? How about 3/3 or 1? So all we're really left with is 9 x to the 4/3. You're like, well, where'd the exponent go? If you want to put a 1 there, you can. It is 9 to the 1st power, or just 9x to the 4/3. I'm okay either way. How are we going to handle this? We can't. Not in this form. I cannot multiply these together unless they have the same root. So what do we have to do? M to the 3/5, m to the 1/2. Exponent, root, denominator. Exponent, 1, root, 2, denominator. Okay? Now I can get an answer to this if I can do what with these? Add 3/5 plus 1/2, common denominators, 6/10, plus 5/10. How about m to the 11/10? This just made this question solvable. We can now simplify this. There's something we can actually do with it. In the past we were stuck. Now we can actually combine these. In the past we were stuck. I cannot cancel out a third root and a square root. But p to the exponent over root. P to the exponent over root. What can I now do? I can bring these together as long as I take the exponents and what? 5/3 minus 1/2 about 10/6 minus 9/6. This is just p to the 1/6. I think that's cool. This now is something that we can bring together. This whole mess is the same answer as the 6th root of p. Okay, so we can now simplify things that we couldn't in the past. Pretty easy section. Kind of tricky some stuff on it, but work through it and let me know if you got any questions.